In this lecture, we will see the schematic diagram of a CMOS inverter. We will draw the schematic in twisted form and the untwisted form. This will help us to draw the corresponding layouts. So at first, let's see the symbol. So this is our CMOS inverter. CMOS inverter is otherwise known as the NOT gate. So let's see the symbol of a NOT gate. The symbol of a NOT gate is like this. This is one terminal, this is one terminal, this is the input, and this is the output. The truth table can be written as let's do the truth table. So let's say this is for input and this is for the output. If my input is 0, my output is 1. If my input is 1, then my output is 0. So this is the basic truth table of a CMOS inverter, and this is the basic symbol. Now how you can construct the schematic? Certainly this all the gates are all the logic gates. All the gates are drawn in schematic by using the concept of CMOS. Now what is a CMOS circuit? At first we have to know what is CMOS. It's complementary MOS. CMOS is complementary metal oxide semiconductor. Complementary metal oxide semiconductor. CMOS consists of a, from the name you can understand it's complementary. This is the PMOS. Here there is a NMOS. This is the pull-up network, the pull-up circuit, and similarly this is the pull down. So basically all the PMOS will be drawn in the top, all the NMOS part will be in the bottom. Here will be the input, and from here you'll obtain the output. Now what will be this output? This output will be certainly in the inverter format. So now you understand why in the first lecture we had mentioned that you need to have bit knowledge on VLSI. So one has to know what's the use of the CMOS, how this from the CMOS you can construct the gates. For each lecture we will be mentioning, we will be saying how to draw the schematic, but still one has to know how the output gets inverted. Okay, so now we'll see the CMOS logic of a inverter. CMOS logic of a inverter. As we know that the AND is represented in the form of NMOS in series and PMOS in parallel, and the OR is represented as the reverse. That is, dot operation is represented as NMOS in series and PMOS in parallel, and the plus operator is represented as NMOS in parallel and PMOS in series. And whatever output you obtain after the PMOS and NMOS circuit, the output is certainly the inverted form. That is, if you have thought of A and B, then the output obtained will be A and B bar. Okay. So when we talk of CMOS logic of an inverter, how you can construct, because the number of input is 1 and the output is also 1. Output is not that mandatory, but mean is the input, that is 1. For a single input, how will you construct? So if it's single input, then the number of NMOS needed will be, or N MOSFET needed will be 1. PMOS needed will be also 1. We need the output as A bar. If my input is A, then my output has to be A bar. Then whatever I give at the input, as we know from the complementary logic, that whatever the input, the output is the complementary of the input, then certainly my input will be A. So now let's see the schematic of the CMOS logic, the CMOS inverter. At first we will see the normal schematic diagram of CMOS inverter. Let's mention it as the normal schematic diagram. The normal schematic diagram of a CMOS inverter. So for a single input, we need single PMOS and single NMOS. So there will be no series and parallel. So in our pull-up network, we will have one PMOS. Similarly, in the pull-down network, you'll have one NMOS. Now, this is the source. So now label the source and the drain. This is PMOS. At first, let us label the PMOS and NMOS. This is PMOS, so let me write it as P. This is NMOS, so this is N. This is the drain, sorry, this is the source. This is not the drain. So this is the source of PMOS. This is the drain of PMOS. This will be the gate terminal of PMOS. Similarly, this is the drain of NMOS. This is the source of NMOS, and this terminal is the gate of NMOS. We all know that the source of PMOS, the source of PMOS is always connected to is connected to VDD or the source, and the source of NMOS is connected to ground, or you can write it as GND. Okay, so over here this is the source of the PMOS, so this is connected to VDD. This is the source of the NMOS, and this is connected to ground. Next, the input is given at the gate terminal, and output is obtained at drain terminal. These are the four things that has to be kept in mind. So this is the gate of the PMOS, this is the gate of the NMOS. So these two are shorted, and this is another point. So now the input is given at this terminal, and the output will be obtained over here. So this is in and this is out. Now this is the normal schematic diagram of a CMOS inverter. So before going to the twisted schematic, we can draw the layout directly from here, or we can take the twisted schematic first, then we can start drawing the layout. Now what do you mean by twisted schematic? Twisted schematic means the NMOS and PMOS will be twisted. So here is the twisted schematic. Twisted schematic diagram of a CMOS inverter. Now twisted. Twisted means we have to twist the PMOS and NMOS as mentioned. How do we twist? Twist the PMOS and NMOS. How can we twist? Because the normal form is this. This for the case of PMOS, and for the case of NMOS, the normal schematic, the normal form is this. This is the NMOS. So how you can twist it? You can twist it as this. Secondly, you can twist it as this. Twisting it as this is also possible. So this is one form, this is the second form, and this is the third form. Now twisting the NMOS will be similarly like this. This is the first form. The second form will be like this, and the third form will be this. Okay, now according to us, which will be more beneficial for us, we'll take that. If we take the first one, this is the, we can name it as, suppose this is source, drain and gate. Maybe this is also source, drain and gate. Source, gate, and this is the drain. Similarly over here, if I give it as source, gate and drain, source, gate and drain, source, gate and drain. So now if I take this to twisted, so my diagram will be complicated if I give the input, because we know we have to join the gates, the shorter terminals of the gates. At the shorter terminals of the gate, you obtain the input. So if I pick only this one, so certainly this and this is not possible. This and this will be a bit complicated. You can directly see it from here only. If I join this gate and this gate, so it has to go somewhere like this, then source here, then drain. Okay, fine, connected here, but there will be a problem with the input. If I take the second one with this one, then somehow okay, because the gate, connect the gate from outside, and source and drain, no problem. If I take these two, okay, let me show you how to, we'll take one by one case and see which is more appropriate for us. So first, if you take, we go to the previous one and see this one and this one. Okay, we take the first two, then it will be, this is the PMOS and same will be the NMOS. Okay, now how will you join it? First mention the sources, and this is source for PMOS, drain for PMOS and gate for PMOS. This is the source of NMOS, drain of NMOS, and this is the gate of NMOS. So now this source is connected to VDD. This is connected to ground. This is the PMOS and this is the NMOS. Now the input directly you can join like this, so certainly go from here like this, and this is the input, and from here there will be connection between the two drains, and this is the output. This is one. If we take the second possibility, then that is keeping constant this and keeping this constant, and then changing this. Then the second was, this was the PMOS, this was the NMOS, this is the PMOS, and this is the NMOS. This is the source, this is the drain, and this is the gate. Similarly, this is the source of NMOS, this is the drain of NMOS, and this is the gate of NMOS. So we know the source is connected to VDD, it's connected to VDD, and the source of the NMOS is connected to ground. The drains are shorted, this is the output, and the input is obtained from gate. So either you can short from here or you can short from here. So let me short from here. You can say there's no much complicated, there's no complexity over here, because this is just a schematic, but you'll face a problem when you draw the layout. That's the reason why we are taking the twisted schematic. So here there's a connection problem for gate, here there will be connection problem in gate. So if you take these kind of combinations, then one will face problems, one will face problems while drawing the layout. So you should take a twisted form that will make your procedure for drawing the layout easier. So take the combination of 1 and one of PMOS and two of NMOS. Okay, so what does this mean? That taking the combination 1 for PMOS and 2 for NMOS. This was 1 for PMOS and 2 of NMOS. So after taking these two combinations, let's see what kind of schematic diagram we get. We'll take the next page. So final twisted schematic will be obtained now. So 1 of PMOS will be okay, this was not the one. This is the PMOS and this is the NMOS. This is the PMOS and this is the NMOS. So if you want to give the name of the terminals, this is source of PMOS, this is the drain of PMOS, and this is the gate of PMOS. So now this is the source of NMOS, this is the drain of NMOS, and this is the gate of NMOS. Now the source of PMOS is connected to VDD, and the source of NMOS is connected to ground. Now the two gates are connected. Connect from here to here. This is our input and the two drains are connected, which will give you the output. So this is the input and this is the output. So this is the final twisted diagram. This is the final twisted diagram of a CMOS inverter. Now how will you convert it to the layout form? You need to just draw these points, that is the terminals, the sources, the drains and the gate terminals, and then do the connections. First thing to keep in mind is that this is the gate terminal, right? There's a shorting between gate terminal. This shorting is done by the poly layer. The poly layer is red in color, so I have taken a poly layer, and all other metal connections will be like this VDD. This will be given in metal, and the metal is a blue layer, that's actually metal 1. Similarly with ground, this should be also the metal 1. This connection, this whole connection will be done with metal 1. Similarly, these connections, this part, then this part, this part, these parts, these all parts will be done in the metal connections. So metal 1 is used for the connections, and poly is used only at gate, only at gate. Now before going for the terminals, where are these terminals? It's in PMOS and NMOS. So you have to know how to construct this PMOS and NMOS. Now for PMOS, we need the, if I take PMOS, then you need a P diffusion layer, P diffusion layer. Now this will be inside. Outside there will be a N-well layer. This is the PMOS. And for the NMOS, you need only the N diffusion layer. The N diffusion layer will construct the NMOS. Then if you want to contact this metal with, see here these are metal, but over here this part you will construct using this. This part will be constructed using this. Similarly, this part will be constructed using this. So there will be a connection between the P diffusion layer and a metal layer. So what will you do when there is a interlayer connection? So we have various contacts for the interlayer connection. For interlayer connection. So what kind of contacts are there? You have P diffusion contact, N diffusion contact, then poly contact. So these are the diffusion contacts. Similarly, we have some P-well contact, N-well contact. These are for the sources. These are meant only for the sources. These two contacts will be given only to the sources, that is the VDD. The VDD will have N-well contact, and the ground will have the P-well contact. So now let's see the layout of a CMOS inverter. the layout of a CMOS inverter from twisted schematic. From the twisted schematic diagram. So at first you have to draw the anvil. So the anvil is usually black in color, so I'll take black for the anvil. So this is the anvil. Inside the anvil you have P diffusion. So P diffusion is brown in color, so take a brown color. So this is the P diffusion. Now of the same area you need the N diffusion layer. The N diffusion layer is green in color. You can just extend this. So this is the N diffusion layer. Okay. Now we have to place the gate. So you can see now the construction of the PMOS and NMOS is done. You can write also here, this is the PMOS and this is the NMOS. We know that the gate is constructed using poly, and poly is red in color. The poly connects the gate terminals. Okay, so this is the poly layer. Poly. Okay, so this is the gate, this is the source, drain, this is also the source, this is also drain. Now the source of the PMOS is connected to VDD. So this is VDD and this is metal 1, and the source of the NMOS is connected to ground. This is also metal, and since this is the input, the output is obtained across the drain terminal. This is the out. So this is out, this is the input, this is the output. Now for placing the contacts, let me take the black line here. Okay, before that, let's extend this layer of VDD. If you want to erase, then erase, and just extend the layer like this. This is metal. Similarly, extend this crown. Okay, you want to place the contacts. First you have to place a contact over here so that this metal gets connected with this P diffusion. So there will be a contact over here. Similarly, there will be a contact over here, and over here, and a contact over here. These contacts are the P diffusion contact. These contacts are the N diffusion contact. Okay, now in this VDD and ground you have some more contacts, as you can place as many as you want. This is the N well contact or the N substrate contact. Similarly, if you want, you can place a contact over here. This is the P substrate contact or the P well contact. This is the layout of a CMOS inverter that is drawn from the twisted schematic. Now let's see the layout of a CMOS inverter that is drawn from the normal schematic. So if you want to draw the layout from the normal schematic, then at first write it. I think this is layout of a CMOS inverter from untwisted schematic. From the untwisted schematic. Now for the untwisted schematic, the PMOS will be like this. So at first place the N well, this is the N well, which is black in color. Then the P diffusion layer. This is the P diffusion layer. P diffusion. Then of the same area you need the N diffusion layer. This is the N diffusion layer. So first mention the terminals. This is gate, this is source, this is drain. This is the gate, source. Okay, we can take this as the drain and this is the source. So first you have to connect the gate terminals. You will not label this drain and gate. If you want you can do, but this is just for the convenience. Connect the gate terminal. Okay, this is poly. Now the source of the PMOS, as we know, this is the PMOS. You can write here, this is the PMOS and this is the NMOS. So you have to connect the source of the PMOS to VDD. You can connect from here or you can take it from here. This is metal one and this is VDD. Similarly with the ground. Is also the source. This is ground. Now these two drains are to be shorted. And you obtain the output from here. So if you want you can just extend this like this. You can extend the poly. So this is the input. This is the output. Now we have to place the contacts. Place the contacts. First contact will be the contact between the metal layer and the P diffusion. So this is the P diffusion contact. This is the N diffusion contact. This is the P diffusion contact. This is the N diffusion contact. Similarly, this is also a P diffusion contact. Over here there will be a N diffusion contact. And in the sources we need substrate contacts or the N well and P well contacts. So this is the N substrate contact and this is the P substrate contact. When you use commands in Magic, you write it as NWC or the N well contact, and this as PWC, that is the N well contact, and this as the P well contact. And for the P diffusion and N diffusion contact, this is the PDC, this as NDC, and this is the short form for N diffusion, and this will be the short form for P diffusion. For metal one, write M1. For poly, type poly. This is actually diffusion, but you actually write NDiff. Similarly over here, this is written as P diffusion or the PDiff. So this is the layout of a CMOS inverter that is drawn from the Untwisted schematic diagram, and these are the different layers that has been used.